Suppose z is given implicitly, z equals a function of f of x and y, and it's put in the form of f of x, y, z equals 0. Now the chain rule will allow us to find some partial derivatives. So if I take the partial with respect to x, I'll have the partial of f with respect to x, partial of x with respect to x, plus the partial of f with respect to y, and then the partial of y with respect to x, plus the partial of f with respect to z, as a partial of z with respect to x. And all this would be equal to 0. Now notice that z is a function of x and y, so this partial of z with respect to x is something. But y with respect to x is in fact a constant. So because of that, this will go to 0. And of course, the partial of x over the partial of x this is just 1. So what this turns out to be is the partial of f with respect to x plus the partial of f with respect to z, partial of z with respect to x equals 0. So now I can solve for the partial of z with respect to x. And if I rewrite this in the form or using this notation, what that gives me is a partial of z with respect to x will be equal to negative partial of f with respect to x, partial of f with respect to z. Now, similarly, if we work this out as a partial with respect, or finally looking for the partial of z with respect to y, I will end up with the partial of f with respect to x, partial of x with respect to y, plus the partial of f with respect to y, the partial of y with respect to y, partial of f with respect to z, partial of z with respect to y equals 0. Now partial of y over y, that is going to be 1. And x with respect to y is 0, so this whole thing is going to be 0. So this would then give me, using the other notation, partial of f with respect to y plus a partial of f with respect to z times the partial of z with respect to y. And that then tells us that the partial of z with respect to y is equal to a negative of the partial of y over partial with respect to z. And notice the third option, the partial of z with respect to z doesn't make any sense. So basically what we have is these two partials that come in the form that we just saw earlier because we now have this implicit function of x, y, and z. So let's go ahead and find the partial of z with respect to x and the partial of z with respect to y given this function x, y, z equals cosine of x plus y plus z. So the partial of z with respect to x we said was equal to the negative of the partial with respect to x over the partial of f with respect to z. So f in this case is going to be equal to, see, f of x, y, z will be equal to x, y, z minus cosine of x plus y plus z equals 0. See, now I have this in that form that we needed. So the partial of this with respect to x, this is look for these individual components. I'm going to go through this with respect to x. So everything else is a constant. So with respect to x, the partial here is going to be simply y times z minus, there's an x in here, so the derivative of cosine is negative sine, so I have a double negative, that's plus, sine of x plus y plus z times the derivative of the inside with respect to x, which is just 1. So that just goes away. Well, I can put it there, but who cares? And now see, I need to find the partial with respect to z of this function f. So with respect to z, x and y is now a constant, so that will give me xy. And again, I have plus sine of x plus y plus z. Derivative of the inside is 1. So the partial of z with respect to x is going to be the negative of the partial with respect to x of this function f, once it's set equal to 0, over the partial with respect to z, which in this case is going to be the negative of yz plus sine of x plus y plus z divided by xy plus sine of x plus y plus z. Now you may or may not want to move this negative in. I mean, I'm kind of good with it as it is. So I also want the partial of z with respect to y. That's what I asked for here. I'm going to need, well, this is actually equal to the partial of f with respect to y over the partial with respect to z. So I have all the pieces except for the partial with respect to y. So let's do this down here. If I go through this function again with respect to y, x and z become constants, so this would be xz plus sine of x plus y plus z. And so now I have a negative of xz plus sine of x plus y plus z over the partial with respect to z, which is still xy plus sine of x plus y plus z.